Good afternoon and welcome to lecture 18 of ETC 779. In this particular lecture, I will try to complete the remaining part of sensitivity analysis and I will introduce you to one new concept, that is break-even analysis. In yesterday's lecture, I gave you the basic background of sensitivity analysis. Basically, sensitivity analysis aims to identify the highly sensitive variables, the less sensitive variables and insensitive variables. Now, sensitivity analysis can broadly be performed for two broad cases, one which involves single alternative, second which involves more than one alternative. In each of these two cases, we have got three specific conditions. Condition 1, it involves change in a single variable at a time. In condition 2, we are able to change two variables at a time, and in condition 3, we can have changes in more than two variables at a time. Condition 1 and 2 we had already discussed in previous lecture. In today's lecture, I will show you how to perform sensitivity analysis which involves changes in more than two variables at a time. Now, this type of sensitivity analysis is also known as scenario analysis. So, what is scenario analysis? The sensitivity analysis related to changes in more than two variables at a time is known as scenario analysis. So, in this I will introduce you to two problems which will reinforce your concept of scenario analysis and how it is performed. Now, scenario analysis is considered the best approach while performing sensitivity analysis involving changes in more than two variables at a time. Now, what we do in scenario analysis? We try to prepare different scenarios. What are these scenarios? One possible scenario could be the best, there could be a worst scenario, and then there could be a normal scenario. In best scenario, what we assume? We assume the most favorable values for all the variables under consideration, and that we are terming as either the best scenario or calling it as more favorable scenario. So, either you call them as best scenario or you call them as more favorable scenario. Opposite of this is worst scenario, in which we assume that the values of different variables will be the worst. They will be taking the worst values, the most negative values or the most unfavorable values, that we are terming it as worst scenario, or else we also call them as less favorable scenario. So, we have best scenario or more favorable scenario, other extreme we have worst scenario or less favorable scenario, and the middle one which we call normal scenario. In that we assume the variables values as the most likely values, and sometimes this normal scenario is also termed as objective scenario. So, there are two nomenclatures which are quite common. According to one nomenclature, we have best scenario, worst scenario and normal scenario. According to other convention, we call them as less favorable scenario, objective scenario and more favorable scenario. So, these are popular terminologies used in scenario analysis. Now, how do we perform? I will tell you through one illustrative example. But the basic objective of conducting scenario analysis is to get a feel. For example, what happens under the most favorable scenario? What happens under the most unfavorable scenario or most adverse scenario? And what happens under normal scenarios? So, corresponding to these three values, we will try to find out either the net present worth or the annual worth or the rate of return. And we will try to analyze whether the net present worth is in positive for even the worst case, or is my rate of return more than the minimum attractive rate of return even for the worst case. So, such type of feeling we want to have through this kind of scenario analysis. So, you understand the objective? The objective is written in this particular slide. If you note down this particular slide, it says the objective of such scenario analysis is to get a feel of what happens under the most favorable or the most adverse configuration of key variables. For example, the best, the normal and the worst, right. Now, we will show you through an illustration how to conduct this scenario analysis. You can note down this problem. We have taken the same problem for which we conducted different sorts of sensitivity analysis. For example, changes in one variable at a time, changes in two variables at a time. Now, the same problem we will show you how to conduct scenario analysis, that is changes in more than two variables at a time. So, if you see the normal column, the data is exactly repeated from the past problems. You can see the incoming variable at 100,000, outgoings 5,000. I am reading the normal column, right. Salvage value 50,000, interest rate 12%, service life 10 years. So, this is the data which has been reproduced from previous problems, and this, since we have estimated them as the most likely values, we are calling them the normal scenario. Now, I have to constitute worst scenario. That means, I have to assume those values which are unfavorable as far as all the values of variables are concerned. For example, incomings, if you see the worst scenario, I have assumed it to be 85,000. Now, from my past experience, I anticipate that my incomings can't go below this particular 85,000 value. So, that is why I have kept this under worst scenario. If you look at the best scenario for this variable, I have assumed 115,000, thinking that no matter what I do, I am not going to get more than 115,000 every year for next 10 years. So, that has been clubbed under best scenario. Likewise, I have assumed the most unfavorable values of different variables for worst scenario. For example, outgoings, I have taken 7,000 under worst scenario. Salvage value, I have assumed low. So, from 50,000 I have assumed only 25,000 under worst scenario. Interest rate, I have assumed a high value 15%. Service life, I have assumed lesser value, 8% only. So, if you notice the worst scenario column, you will find that I have tried to take the most unfavorable values for all our variables under consideration, and just the opposite has been done for best scenario. So, if you look at the last column, incomings value has been taken as 115,000. Outgoings I have reduced because that will be a favorable situation for me. I have assumed it to be 4,000. Salvage value I anticipate little bit higher, 60,000. Interest rate I assume a lower value. Under normal situation it was 12%, now I am assuming only 10%. Service life, here again I am having a optimistic value, 12 years. So, what I have done is I have taken the values of different variables corresponding to 3 scenarios. One, under most likely condition, which I am calling as a normal scenario. Second, under worst condition, which I am calling as worst scenario. And finally, the best one, I am calling them as best scenario. Now, in some textbook, instead of worst, they will be writing as less favorable. So, do not get confused, both are same only. Some people call them as worst, some textbook they refer to them as less favorable. The normal column in some textbook you will find them as objective scenario. So, normal is replaced with objective terminology, and finally, the best is replaced with more favorable terminologies in some textbooks. But the idea here is we are generating different scenarios, and then I am trying to evaluate how my net present worth changes, how my annual worth changes, how my rate of return changes. As I told you in the previous lecture, sensitivity analysis can be performed for any of the evaluation methods that we have studied in this particular course. Although for our convenience, we have been solving problems using net present worth. Now, what we have to do next? Corresponding to all these 3 scenarios, I have to calculate the net present worth. So, find out the net present worth for all the 3 scenarios. In the previous lecture, we have already calculated the net present worth for normal scenario. If you remember, it was coming to be about 52,000 in plus side. Positive net present worth we were getting for normal situation. Now, we have to calculate the net present worth for worst scenario as well as for best scenario. I have done this for you. You can note it down and you can cross check these values at your own end. For example, in this particular slide, I have given you the computations for net present worth under worst scenario. So, it would be equal to minus 500,000 plus 85,000 multiplied by P given A at an interest rate of 15% for a period 8, minus 7,000 multiplied by P given A 15% for a period 8, plus 25,000 multiplied by P given F at an interest rate of 15% for a period of 8 years. So, if you take the values of different factors, you will find that you are getting a net present worth equivalent to minus 141,000 816.54. So what is happening here? I am getting a very high negative net present worth. That means there is a risk involved. In normal situation, if you remember, I was getting plus 52,000 some value. Whereas if the worst scenarios prevail, my net present worth turns out into a high negative value. Just to complete this calculation, you just have a look at net present worth under normal situation. This is what we had done yesterday. So as you can notice from this particular slide, net present worth under normal situation, normal scenario is coming to be 52,869.4. Now let's move to the third scenario, which is the best scenario. So methodology of calculating the net present worth remains same. It would be minus 500,000 plus 115,000 P given A at an interest rate of 10% for a period of 12 years minus 4,000 multiplied by P given A at an interest rate of 10% for a period 12 years, and finally plus 60,000 multiplied by P given F 10% 12 years. And you find the net present worth equivalent to 275,437.39. So the question before us is what to do now? Should we go for acquiring that particular asset at 500,000 or should we not do this? That is why at the bottom of the slide you can note down, I have written what is the decision. So what I have found here, under normal situation I am having a fairly positive net present worth. Similarly, for best situation I am having a very high value of net present worth. But if my variable changes to worst scenario, it may give me a very high negative net present worth. So what would be my decision? I may say that it is not worth buying this particular equipment. But some of you may say that it is worth buying the set of equipment at 500,000. So what happens? Different people, different decision maker may take different decisions under such situation. That is why one of the drawbacks of scenario analysis is that different people, rather different decision makers can analyze the situation differently and arrive at different decisions. So that is one of the major drawback of scenario analysis. But its advantage is at least it is giving you a feel of it, that this is also one of the possibilities. But decision making will be dependent on the perspective of decision maker or his behavior. Suppose some decision maker is risk averse, so he will not select this equipment. He will assume that worst scenario might prevail and it is not preferable to go for this equipment. Whereas a person who loves taking risk may go for buying this particular piece of equipment. He may think that under normal situation I am getting a plus value, under best situation I am getting a still higher value of net present worth. So let us go for buying this particular piece of equipment. So, depending on how you view the risk, how you take the risk may change your decision under such circumstances. Now, we take another problem. Now, here again for this problem, I have 3 sets of scenarios. I have normal scenario, I have best scenario, and I have the worst scenario for different variables. Now, corresponding to those values of variables, let us say I have got these values of net present worth. If you see the first line, net present worth of worst scenario, I am getting minus 3000. If I see the net present worth under normal scenario, I am getting plus 150,000. And if you see the last one, the net present worth of best scenario, I am getting plus 250,000. Now, can you tell me what would be your decision? If you see this particular data, most of the people, even if they are afraid of taking risk, will like to go for such option, because they find that even if the worst scenario prevails, there is very little that they can lose. Whereas, if they see the gain, it is substantially higher. So, the risk involved here is less. So, most of the people would like to go for such alternative, where under worst scenario there is very little possibility of making loss, or rather there is little loss involved, whereas if normal and best situations prevail, they have got good money which they can gain. So, is it clear to you? I have given you 2 problems, they are giving you a feel of it under different scenarios. Again, decision would be different, it might be same for some cases, but most of the time different decision makers may arrive at different decisions, but at least you are able to weigh different pros and cons of going in for this particular alternative or rejecting this particular alternative. You are getting more clarity, and that is one of the prime objectives of conducting the scenario analysis. Now, are you able to find out the difference? Just before yesterday's class, we were treating everything to be constant. So, we were dealing with all the time normal situations, thinking that whatever estimate I have made is sacrosanct, but in real life situation it is not so. After all, it is your estimate only. An estimate can go wrong also. If not entirely wrong, there may be slight variation in your estimate, and that may have implications on your decisions that you might have taken, thinking that your estimate is correct. So, this is the fine difference that you might have noticed between maybe previous lectures and past 2 lectures. Now, here again I would like you to remind that till now we are not putting any probabilistic values for different scenarios, but the further advanced version of this would be assigning different probability values to different scenarios. That would be one step ahead. For example, I say that there is a 15% probability that worst scenarios would prevail. There is 30% probability that best scenarios would prevail, and there is 55% probability that normal scenarios prevail. So, once you have assigned certain probability values to different scenarios, that type of problem comes under risk analysis. We will see how to carry out risk analysis for such kind of problems. But as far as sensitivity analysis is concerned, scenario analysis is concerned, we are nowhere talking of probability values associated with different scenarios. So, this point please make it very clear that sensitivity analysis is non-probabilistic in nature. Nowhere we need to consider the probability values associated with different scenarios. Now, these are some of the advantages of scenario analysis. Obvious advantage is that you can change more than 2 variables at a time and see the impact of your decision under best situation and under worst conditions. So, that is why it is considered superior than the sensitivity analysis involving single variable changes at a time and 2 variable changes at a time. But while these are the advantages, there are certain limitations of scenario analysis also. For example, the first limitation of such scenario analysis is the assumptions that there are very few well delineated scenarios. This may not be true. See, you might have noticed that we considered only 3 scenarios in our previous problem: normal scenario, best scenario and worst scenario. There is again assumption involved that I am able to forecast all the possible scenarios. There could be thousands of scenarios possible, but we are not trying to explore all the scenarios which may exist in future, and that is one of its limitations. We are trying to classify everything into 3 or 4 categories of scenarios only. Now, if you want to explore different kinds of possible scenarios, in such cases we carry out simulation analysis. That is a separate chapter, separate area itself, that you might be covering it in 772 course, which is quantitative methods. So, in simulation analysis what we do? We try to replicate, we try to imitate the real life situation into mathematical models. For example, we may have 2 extremes of incomings, 85,000 to 115,000. We saw it under worst situation, under worst scenario and under best scenario. Under worst scenario my incoming was 85,000. Under best scenario I had assumed it to be 115,000. Now, in simulation what we will assume, that between these 2 extremes 85,000 and 115,000, there could be infinite possibilities that are existing which may occur in real life situation. So, that is a separate area itself. We are not going to devote too much time at this point of time. Now, the another limitation of scenario analysis, if you see, there is a huge requirement of data to perform scenario analysis. You might have noticed that we had 6 variables in our previous problems: incomings, outgoings, salvage value, interest rate, service life and so on. 6 variables we had taken. Now, for 6 variables, how many data set we had to generate? if there were 3 scenarios, the data set that would be required would be 6 into 3, 18. If there is 4 scenario that we are taking, then the possible data set needed would be 6 into 4. So, the requirement of data is huge, and that is another limitation of this scenario analysis, because if you have more number of variables and if you want to analyze more number of scenarios, the data requirement would be quite substantial, and that is why it is one of its limitations. We do not extend this analysis for situations involving more variables or situations involving more scenarios. So, these are certain limitations of scenario analysis. So, under sensitivity analysis, we have covered all the 3 conditions under single alternative. If you try to recollect the diagram which I had given you in previous class, I will show it again. If you go back to lecture 17 and try to see this particular slide, you can tell me where I am right now, how much I have covered. Till now I have covered the single alternative, all the 3 cases. So, in single alternative you can find there is a change in one variable at a time, this has been covered. Change in 2 variables at a time, this also has been covered, and in today's lecture I just now covered change in more than 2 variables at a time. Now, if you see the center part, a spider web diagram I used for showing the impact of changes in different variables one at a time. Family of curves as well as isoquants I used to show the analysis results involving 2 variable changes at a time. And finally, scenario analysis I explained you, which involves changes in more than 2 variables at a time. Now, I have to concentrate on the right side of this particular diagram. That means, now I will show you the condition in which there are more than one alternative involved in the problem. I call them, let us say, as alternative A1 and alternative A2. Now, there also I can perform sensitivity analysis, and there again I can have one variable change at a time, 2 variable changes at a time, and more than 2 variables changes at a time. So, this is what is left out in this particular discussion. The last 2 things, the change in 2 variables and change in more than 2 variables, are slightly complicated. This I will cover when I come to see you personally in Ethiopia. Whereas, as far as this lecture is concerned, I will take change in one variable at a time involving more than one alternative. That is what is we are going to learn now. And for this, I will straight away go to a problem which you can note it down. If you see this problem carefully, the data for alternative 1 is already with you. This is what we have been discussing throughout this particular lecture as well as previous lecture. It says acquisition cost is 500,000, incomings 100,000 for next 10 years, outgoings 5,000 every year for next 10 years, salvage value 50,000, interest rate 12%, service life 10 years. So, this set of data is already with you. Only thing I am telling them is, I am telling you now is, this relates to alternative A1, let us assume. And now I have another alternative with me. I call that as alternative 2. Alternative 2 requires 400,000 as acquisition cost. It is also known as first cost. For this alternative, the incomings are 80,000 every year for next 10 years. The outgoings are 10,000 per year for next 10 years. The salvage value is rupees 40,000. Interest rate again is 12% and service life again is 10 years. Now, under normal situation, suppose you are not at all doing sensitivity analysis, which alternative you would choose? So, that part is common and that is the first step in sensitivity analysis. Assume everything to be constant, find out which alternative is preferable. That means, you can calculate the net present worth corresponding to both the alternatives separately. Net present worth of alternative 1, net present worth of alternative 2. Remember, again I am insisting that instead of net present worth, you could have attempted this problem by any other evaluation method. It could have been annual worth comparison, it could have been rate of return comparison, it could have been future worth comparison. But for this particular problem, try doing it using net present worth. For alternative 1, you have already calculated the net present worth. It is, I believe, 52,000 something. Yes. Now, for alternative 2, you calculate the net present worth. I have made the calculations for you. If you see the first two lines, it is giving you the net present worth of alternative 1 as well as alternative 2. Now, I will tell you what to do from here onwards. You could have done the cash flow part for both these alternatives also. For alternative 1, the first cost is 500,000, then every year 100,000 is your incoming, 100,000 per year for next 10 years, year 1, 2, 3, so on up to year 10. Now, your outgoings are also known to you. It is 5,000, 5,000, 5,000, so on. And in addition to this, you have a salvage value equal to 50,000. This is for alternative 1. Now, similar cash flow diagram you can plot it for alternative 2 also. It is 400,000, this one is 80,000 every year for next 10 years. So, year 1, 2, 3, so on. Salvage value is 40,000 and your outgoings are 10,000. So, this is as far as alternative 2's cash flow diagram is concerned. the net present worth, if you find, I have already calculated, please cross check it. I will write it in this particular slide itself. Net present worth I am getting here is 52,869.4, and for this alternative 2 I am getting a net present worth of 8,394.2. So, if we assume that the values of variables are fixed, they are not going to change, then our decision would be to go for alternative 1. Decision is choose alternative 1. Why? Because I am getting a higher net present worth. Now, I want to perform the sensitivity analysis, and that too involving one variable changes at a time. So, let us take life as one of the variables which I am going to change now. That means I am interested in knowing the answer of what happens if my service life changes from 10 years to 8 years, from 10 years to maybe 12 years. Is my decision still the same or has it changed? So, if I perform this set of computations, I am going to understand the sensitivity of life as far as the two alternative selections are concerned. In another example, you can study the impact of change in maybe incomings. So, what sort of answer you will get while performing the sensitivity analysis? If your incoming value for alternative 1 changes from 100,000 to maybe 85,000, will you still go for alternative 1 or will you reverse your decision? So, that kind of answer basically we are trying to extract from sensitivity analysis. And how do we present this set of result? That I am going to show you now. On vertical axis, y axis, let us put present worth. This is in plus side, this is in minus side. This is 0. Here let us take n or the life. This is on x axis. You may get a curve like this. This may be for alternative 1. This may be for alternative 2. Let us say they are meeting at some point n is equal to 7. I am just taking a hypothetical example. You please work it out with the data that is given to you. Let us say this is n is equal to 7, this is 5, this is 3, this is 1 and so on. This is 9, 11 and so on. So, what I have done? I have kept life in years on x axis and present worth on y axis. Now, can you interpret this diagram? It says that it would be better to go for alternative 2 if you expect that life is more than 7 years. If you see this particular problem, it could be alternative 1 and this could be alternative 2. If you want to talk in terms of this particular problem, what do you find here? If the life is more than say 7 years, it is better to go for alternative 2. Why? Because for alternative 2, you find a higher net present worth. From year 7 onwards, we are getting high net present worth for alternative 1. Whereas, if I find that the life of the equipment is going to be less than 7 years, which one is better? Alternative 2 is better. Why? Because my net present worth is more than that. Now, this diagram relates to the change in single variable, that is life. Similar type of diagram I can plot for other variables also. And on x axis, I can show even percent deviation, like you saw yesterday. These graphs can be plotted in terms of either the absolute values or in terms of percent deviation from the current estimated value. So, what you do for this particular problem, you take few more variables and try to develop this type of curves. And then try to interpret it. These sorts of diagram will also tell you which variable is more sensitive and which variable is less sensitive. How do I know that? Suppose I find that if the life of equipment comes down from 10 to 9 and my decision changes. So, for what percent change my decision has changed? Maybe 9 to 10%. So, even if my estimate of life goes wrong by 10 or 15%, if I find that my decision is changing, in such cases I term that particular variable as the most sensitive variable. So, what I do from here onwards? I will have to be more cautious, I will have to take more action as far as estimate of these variable values are concerned. If I find that some variable is very sensitive, in such cases I may even go for hiring some consultants also who are experts in this field. They can help me in estimating the very correct value or nearly correct value for these variables, because you can see your entire decision may go wrong even if the variable in question comes down by a slight value, by a slight percent. So, this is the benefit of performing sensitivity analysis. Now, this was the example when only two alternatives were given. There could be situation in which you can have more than two variables also, and you may get a graph like this. I will show you in next slide. It could be something like this. Let us say on this axis I am having present worth or net present worth. This is in plus side, this is in minus side, and let us say here it could be anything such as, let us say I assume growth rate. I may get a curve like this. I call this as alternative C. Then I may have another alternative, I call that as alternative B. And finally, I may have another variable, I call that as alternative A. I can have a diagram like this also, where there are more than two alternatives. Now, how do I interpret it? I will first mark the intersection points. One intersection point is here, another intersection point is here, and finally the third intersection point is here. Let us call them as G1, G2 and G3. Extend the point of intersection on x axis and mark them as G1, G2 and G3. Now, it is easy to interpret. If you estimate that growth rate is less than G1, which alternative you will select? I will write this side also. This is A, this is B and this is C. What you find that if the growth rate is less than G1, alternative A is to be preferred. If the growth rate falls between G1 and G2, alternative B is preferred. Similarly, if it falls between G2 and G3, alternative B is still preferred. And if you find that growth rate is more than G3, alternative C is the most suitable one. So, you can write it like this also: less than G1, go for A, between G1 to G3, go for B, and sorry, this is less than G1, and greater than G3, go for C. So, such type of curves can be made depending on the data associated with alternative A, B and C, and relevant decisions can be taken. So, this particular discussion was related to the change in one variable at a time, which involved more than one alternative. In first case, I showed you alternatives more than one, that is 2 in numbers, and finally, just now I showed you 3 alternative situations and how to interpret these curves. Now, with this, I complete my discussion on sensitivity analysis, but I will have to tell you the limitations of sensitivity analysis. The first limitation, which I have been discussing it quite often, is that it is non-probabilistic in nature. Nowhere we are concerned about the probability values associated with different scenarios. Once you include the probability values or the likelihood of different scenarios, that falls under the purview of risk analysis, which we will be seeing later in this particular course. Now, if you look at this particular slide, sensitivity analysis merely shows us what happens to the net present worth or annual worth or rate of return when there is a change in some variable, either one at a time or more than one at a time. And it is not providing us any information on the likelihood of the changes. So, these are some of the limitations. Now, we move on to some more limitations. Commonly in sensitivity analysis, only one variable is changed at a time, which may not reflect the real world situation. Because in real world situation, what you find is that if you make changes in one variable, it will have impact on other variables also. For example, if you change the life of a particular equipment from maybe 10 years to 5 years, the salvage values may change. So, it is not proper for us to assume the change in life without considering the changes in other variables. So, this is also one of the limitations, because most commonly we try to do one variable at a time, and which may not reflect the real life situation. And finally, if you see the last limitation, there is subjectivity involved in the sensitivity analysis. This point was emphasized to you while we were performing sensitivity scenario analysis. There I had given you two examples. In one example, you saw that the net present worth under worst scenario was significantly negative value, while in normal and best scenario, we were getting quite a good positive net present worth values. In second example, you saw that under worst scenario, we were getting very low negative net present worth, and for normal and best scenario, we were getting substantially high positive net present worth. Now, there I told you that different decision makers would take different decisions depending on their affinity or their hatred towards risk, because different people behave differently, they have different attitude to risk. Then sometimes the affinity or hatred toward risk is also dependent on circumstances. For example, I may be risk averse if I see that the stakes of losing are very high. For example, suppose my decision may cost me a loss of $100,000. I may play very safe in that situation, but I may change if I find that the loss, the possible loss if my decision go wrong is only $1 or maybe $10. I am the same person, but my attitude towards risk has changed. Why? Because of the stakes. In first case, stakes involved with losses are very high, whereas in second case, I have changed to a different person because the stakes involved are very low. So that's why I told you the attitude towards risk will govern the decision making, and the attitude towards risk itself may go under change depending on the circumstances. I will give you another example. Suppose your company is in urgent need of getting jobs, getting projects. They may have excess of staff, they may have excess of manpower. Now they are desperate to get projects, new projects, so that they can engage their existing staff, they can engage their existing equipments. So that time they will be desperate. They may be taking the job, taking the project even at low profit margin, maybe 5%. Sometimes there are instances when companies have taken projects even at no profit, no loss. It is the same company, but the circumstances are different. The same company during boom time may not even compromise for less than 20% profit margin. Same company, you have three different scenarios. One is boom time, one is normal time, and one is very crunch time, recession time. So the basic idea of telling you this is scenario analysis may lead to different decisions depending on the traits of the person who is taking the decision, right? And these decisions also will be influenced by the circumstances as well as the stakes of making losses. If the stakes are very low, a risk averse person can be risk loving person. But if the stakes are high, sometimes even the risk loving person can become risk averse person. So with this, okay, before that, these are some of the benefits of performing sensitivity analysis. You can note it down. Already these points are covered. For example, it shows how robust or how vulnerable a particular alternative is to changes in value of different variables. And second point, you can note it down, it enables the decision maker to distinguish the sensitive variables from insensitive variables. Thus, the decision maker can focus its attention in making the estimate of sensitive variables. So these are its prime advantages. So what we have covered in yesterday's lecture and today's lecture is what is sensitivity analysis, what are its advantages, what are its limitations, what are the different situations in which we can perform sensitivity analysis, right. In next lecture we will be covering the break-even analysis. I had planned to do it today itself, but since we have got less time available now, we will not start that particular portion. And basically break-even analysis is also a special case of sensitivity analysis. There we try to find out the break-even point. I will tell you in next class what we mean by break-even point, when break-even analysis is useful, what are its advantages, how to perform break-even analysis under linear assumptions, how to perform break-even analysis for non-linear cases. All these things we will be covering in tomorrow's lecture. So with this I close this lecture, and if you have got any doubts or queries, you may please ask now.
Hello, doctor.
Yeah, please.
My question is based on the second example.
Today's second example.
Yes.
What was the second example?
Could you please show us the slide?
I will just show you.
Minus 3000 net present worth 150 and 250. That small you consider just to show that you can take the risk.
Okay, okay. This one? Okay, okay. This one you are talking?
Yeah, yeah.
Okay.
Yes. How someone choose the worst condition rather than the best? Because gain is better than loss, isn't it?
Can you repeat your question, please?
How someone choose or select a little risk of loss
Little risk.
rather than a better gain?
How a person can accept with little risk.
That again I told you, here again there can be different decisions. Here also people can take different decisions, but I only wanted to say that since the amount involved for worst scenario is very less, minus $3,000 or rupees, one may like to go for this alternative. But again it is a possibility depending on the situation and depending on your behavior towards risk, you may take different decisions which others may not have taken.
But isn't it better to select
Yes, it is better to select.
which have an alternative with better gain or profit?
Yes, it is better to select because even if you encounter a worse scenario, you are losing only 3,000. Whereas, if the normal scenario or the best scenario prevail, you have got an opportunity to make big money. Is it clear to you
Yes, yes.
or not clear?
It's clear.
See, what I have done in this problem is, I have straight away given you the worst value to, NPW corresponding to worst value. These are derived from some data. That data is not shown in this problem. Just to save on time, I gave you directly the values of net present worth. But these net present worth have been calculated based on certain data. That I didn't show you because it is similar thing. You understand how to calculate net present worth for a given set of values. So that step was missing. I have straight away taken the net present worth corresponding to worst, normal and best scenario.
Okay, thank you.
Thank you. Any other doubt?
No doubt.
Thank you and good night.